Hello and welcome. Today, we are going to break down a really important concept in industrial automation, one that's absolutely crucial if you've got a practical exam coming up. We're talking about PLC input wiring, specifically syncing versus sourcing. So think about it. How does a machine's brain actually know you've pressed that big green start button? How does a simple physical action get turned into a signal that the control system can understand? That's exactly what we're going to dive into. Okay, before we get into the wiring itself, we've got to know what we're wiring into. And that brings us to the brain of the operation for pretty much any automated machine out there. Right, the PLC. Now, this isn't your desktop computer. Think of it as a super tough decision-making powerhouse built to survive on a factory floor. Whether it's running a simple drill or a massive conveyor system, the PLC is the one in charge. And to control its world, it first has to sense it. And these inputs, well, they're its eyes and ears. They're usually just simple on or off signals. Yep, the box is in place, or nope, the safety gate is open. But here's the thing. Connecting them isn't as simple as just plugging in a couple of wires. There's a big choice you have to make right at the start. And this is it. This is the heart of the matter. The concept that trips a lot of people up, especially in exams. But trust me, once you grasp one key idea, it all clicks into place. That's it. It all boils down to this one simple question. Where is the power for that input signal coming from? Is the PLC providing the juice for the circuit, or is the switch or sensor providing it? Let's make this super clear with an analogy. Think of a faucet and a drain. In a sourcing circuit, the PLC input is the faucet. It's the source of the water, or in our case, the current. In a syncing circuit, the PLC is just the drain. The sensor is the faucet providing the current, and the PLC's job is to just sync it and complete the circuit. All right, theory time is over. Let's get practical and see what this actually looks like as a real-world circuit, the kind you'll definitely be asked to draw. We're going to walk through this step by step. So no matter if you're wiring, syncing, or sourcing, you're going to see these four key players. And pay special attention to that opto-isolator. It's like a tiny bodyguard for the PLC's logic. It uses a little beam of light to pass the signal along, so if there's a big voltage spike from the factory floor, it can't jump across and fry the PLC's delicate brain. Super important. Okay, let's trace the path for a syncing input. Power flows from your 24-volt supply, goes through your switch, and then flows into the PLC input terminal. See that? The PLC isn't providing the power, it's just accepting it and giving it a path to ground. It's acting like the drain, or the sink. Now, let's flip that on its head for a sourcing circuit. This time, we connect the positive 24 volts first to the PLC's common terminal. Now, the PLC's input terminal itself is hot. It's actively pushing current out through the switch and down to ground. The PLC has become the source of the current. So you might be thinking, okay, why have both? Why make it so complicated? Well, it's not just for fun, I promise. It all comes down to one single critical rule that you have to remember to make anything work at all. This right here is the golden rule. You must always, always pair a source with a sink. It makes perfect sense, right? You can't connect two faucets together and expect water to flow anywhere. You need a faucet and a drain. One device has to provide the current, and the other one has to receive it. And I'm telling you, this is probably the #1 mistake people make out in the field. You can have a perfectly good sensor and a brand new PLC, but if you hook up a sourcing sensor to a sourcing PLC input, nothing's going to happen. No current flows. The PLC never sees the signal. So always check the datasheet for your sensor and wire your PLC to be the opposite. So there you have it. You've cracked the code for how a PLC senses the world. And guess what? These same ideas of sourcing and syncing also apply to the outputs, the part of the PLC that controls motors, lights, and valves. We really hope this explainer helps you nail that concept and absolutely ace your exam.